Hello. In this lesson, we'll take a closer look at HTTP request. For a desktop application, input can come from many sources like keyboard, mouse, webcam, and so on. But for web applications, the main source of input is HTTP requests. So we need to have a good understanding of HTTP requests and what we can do with it. Eclipse provides a nice tool called TCP/IP Monitor, which can be used to show HTTP requests and responses. TCP/IP Monitor functions like a proxy server that sits between the client and the server. Instead of sending a request directly to the server like you would normally do, the client sends a request to the TCP/IP Monitor, and the TCP/IP Monitor then forwards the request to the server. Similarly, the response is sent back to the monitor, TCP/IP Monitor, which then relays it back to the client. So what's the benefit of having TCP/IP Monitor as a middleman? Well, in our case, it allows us to examine HTTP requests and responses, which is something that we cannot do with a browser. Now let's set up TCP/IP Monitor and use it to monitor the access of a web page, like my home page here. Notice that my home page resides on my server sound.custodela.edu. TCP/IP Monitor can be found in the Preferences menu of Eclipse. It's kind of an odd place to put a monitoring tool, but I guess there's no better place for it. If you search for it, you can see it's here. To set up a monitor, we need to provide a few parameters. Remember that a TCP/IP monitor needs to forward requests to a server, so it needs to know where the server is, and that's what the host name and port number are for. My server here is sound.custodela.edu, and the port number is the default HTTP port number 80. So for host name, we'll have sound.custodela.edu, port is 80, and type is of course HTTP. Timeout is 0, meaning connection will never time out, or in other words, the monitor will wait as long as necessary for the server to respond, so we can leave timeout as 0. Also remember that TCP/IP Monitor functions as a server itself, so it can receive requests from the client. Therefore, it needs its own host name and port number. The host name is always localhost because it's running on the local computer, and the port number can be anything as long as it's not a port that's already being used by some service. Normally, I would use port number 6000, which is kind of easy to remember. Okay, now let's start the monitor and see how it works. If we access the web page as sound.custodela.edu, then the request is sent directly to the server. So it doesn't concern the TCP/IP Monitor at all. However, if we change the host to be localhost and the port number to be 6000, the request will be then sent to the TCP/IP Monitor, and then we'll see how the request looks like. As we can see here, from the client's perspective, it's still the same web page, but the request is now captured by TCP/IP Monitor. Notice that here. By default, TCP/IP Monitor does not show the request and response headers. So you'll need to go to the View menu and check Show Headers. We'll talk about HTTP response next time, and for now we'll focus on the HTTP request, which is the left-hand side of the window. As we can see, HTTP request consists of three parts. The first part is called a request line, and then it has a number of headers, and then there's a message body which is currently empty. Later on we'll see an example where some data will be encoded in the message body and be sent to the server. There are three things in the request line: method, request URI, and protocol. Request URI is what we so far call the path of the URL, and we know that in static web it's used to look up a web page on the server, and for dynamic web applications it's used to map a request to a server-side program like a servlet. Protocol is the protocol and version number used by this request, and these days most of the requests are using HTTP version 1.1. The request method here is get, and you can think of request method as a type of the request. For example, there are get requests, post requests, and so on. The term method is used because it indicates the action to be performed on the resource identified by the request URI. For example, get means to retrieve the resource identified by the URI, and we can see why get requests are the most common, because most of the times we want to get the web page. But sometimes we may also want to post some data to a web resource. For example, posting a reply to a topic in a web forum. And naturally, those requests will use the post method. In this class, we only deal with get and post requests, but the HTTP standard also defines some other request methods. For example, put would place a web page at a URL, and the delete would delete the web page at a URL. And those two methods can be used by HTML editors. And then there are some other HTTP methods that are used for diagnosing the server or the network. For example, head, options, trace, and so on. Now that you know what request methods mean, it makes perfect sense now why the servlet methods are called do get, do post, do put, and so on. Basically, whenever a request comes in, the service method in the servlet is invoked, and based on the request method, the request is dispatched to one of those do something methods. We've been using do get method so far because most of the web requests are get requests. The default implementation of this do something method simply return a bad request error. Web programs like our servlets typically need to handle get requests or post requests or both. If your servlet handles both types of requests but produces the same response, you can put the code in the do get method and simply call do get in the do post method. After the request line, which contains method, request URI, and protocol, there are a number of request headers, which are name-value pairs like host, user agent, and so on. Host, as you can see, is the host name of the request this request is sent to, and this field is useful sometimes when the server has multiple names, and depending on which name the request uses, it may deliver different content. User agent tells the server what type of the browser the client is using, and in this case we're using a browser Firefox on Windows. And then there are some request headers that tells the server the capability of the browser. For example, this accept header tells the server that this browser is capable of accepting HTML content, X HTML content, XML contents, and so on. It also accepts the English, and it also accepts the content that's compressed content using the gzip compressing method. Dealing with request headers directly is somewhat rare in web applications, but there are a few important request headers that you should be aware of. For example, you may want to sometimes check the user agent header to decide what browser the user is using, and based on different browser, you may need to deliver different content back to the user. And the cookie is a very important header that is commonly used for session tracking in web applications. And this is something that we'll cover in more details in another lesson. And the referral header is used to track where the request comes from. For example, if I click on a link in a web page, then the referral header of that request will contain the URL of the web page, and that information is useful for online advertisers. I suggest that after class you take a quick look at the HTTP standard and see what HTTP request headers are there and what they are useful. You don't have to read all the details, just very quickly the name of the header and what they are intended for, and that's enough. That gives you an overall idea of what you can get from those headers, and so later on, if you need them, you know where to look for. Now that we know what an HTTP request looks like, let's take a look at HTTPServletRequest, which is a type of the request parameter in the doGet method. As we can see, HTTPServlet is an interface, and there are lots of methods defined in this interface, and most of those methods are called get something, like get cookies, get headers, get method, and so on. And as you can imagine, these methods let us to access various information included in an HTTP request. Now let's do a simple example. We'll write a servlet to display some request information like a method, request URI, and so on. And we'll also display the IP address of the client and determine whether the client browser support gzip compression. So let's first stop the TCP IP monitor again. Go to here and then stop. Okay. Now we'll create another servlet, and I'm going to call this ServletRequest Info. Let's get rid of the comments. And we'll handle both get and post requests, but they will be handled the same way, so I'm just going to call doGet in doPost so that we don't have to write the same code twice. And let's get the output code. So content type, and then let's call this the request info, and let's say we want to know a few things about the request, and let's say the first thing would be the request method, and we can do a request get method. else? Let's see. We have method, there's something called request URI and request URL, and there's also something called context path. Let's see what are the differences. So we have context path, get context path, and then we have URL. Let's do get request URL, and request URI. Let's see if there's any difference. And what else? Oh, the IP address of the client. And if you look at the documentation, the IP address of the client is actually defined in the superclass or the super interface of HTTPServletRequest is here, the remote address, right? Yes. So we'll do remote address or the client address. And let's also check if gzip compression is supported, and that we know is in this accept encoding header, and we want to check if gzip is listed in the accept encoding header. So to get that header, we'll do a request get header, and the name of the header would be accept encoding, and the get header would return the value of that header. And to check gzip, whether gzip is part of the value, we can do index of, I guess, and we can say if index of that is greater than 0, or greater than or equal to 0. If gzip is not in the header, then index of should return -1, if I remember correctly. So anything greater than or equal to 0 would indicate that gzip is in the header. So if this will output gzip supported, and otherwise will output gzip not supported. Okay, let's run this and see if it works. Okay, so the method is get, the context path is CS320. The context path is part of the path that corresponds to your project or your application. Notice that the context path is actually this part. Both URL and the URI actually give the full path, which includes both the context path and also the path that is used to map to your servlet. And The remote address looks kind of weird, but it's actually the IP version 6 address of the local host, since the remote client is actually on the same computer. So it's 00001, and it says gzip supported, meaning that the browser has sent this accept encoding header, and gzip is listed in the value of that header. Okay, so this is our very simple example, and you can take a look at the documentation, and if you want, try a few other get something methods and see what information it provides you. Although request headers contains lots of information, each request header is designed for a very specific purpose. The more general way to get input from the users is not to use the request headers, but use something called request parameters. Request parameters can be specified directly as part of the URL called the query string, and the syntax is simply question mark and then the parameter name, parameter value. If you have more than one parameters, then and another parameter name and another parameter's value, and so on. So that's called the query string part of the URL. And another common way to provide request parameters is to use web forms. Now let's create a simple example that adds two integers from request parameters and then display the sum. Let me stop the server, and then let's create another servlet. I'm going to call this servlet add. Okay, first I'm going to implement the adding of the two parameters and the display in doGet, and later on we'll see what happens if we send a post request. So to get a request parameter is actually quite simple. There's a method in ServletRequest called getParameter. You simply provide the parameter name and it will return the parameter value as a string. So let's say that we'll have two parameters, A and B. So what we do is we say something like integer A is request get parameter A, and that should return the value of the A parameter. The return type of this method is string, and we have to convert that into an integer. So we know the way to do that is simply integer parse int request and that gives us the first parameter, and let's get the value of the second parameter, and then we display the parameters and the sum. And again, let's copy over the display code. Here it's going to be add, and we'll say A plus B equals to A plus B. Okay, so this should do it. Let's give it a try. Run the project. And then we say add, right? we need to provide two parameters A and B. So let's say we say add, and then A is 10 and B is 20. So it shows 10 plus 20 equals to 30. Okay. Pretty straightforward. And the main thing in this example is how to get the parameter inside the servlet. And it's as simple as calling request.getParameter, parameter name, get parameter value as a string, and then if it's not a string, convert it into whatever type that you need. Now, this of course works fine, but what happens if, for example, we provide only one parameter? Well, as you would expect, it gives us an exception, and the exception is number format exception null. And the reason, of course, is because if we don't provide a parameter, then request get parameter is null, and the integer pass int cannot pass a null value. So just like in regular Java programming, we have to deal with different data types. We have to be concerned with null pointers and so on. And in this case, we'll do something like this. We'll say if we'll give A and B a default value. And we'll say if get parameter A is not null, and then we set the value of A if request parameter B is not null, and then we set B's value. Okay, so if we do that, the server is still running. Okay, restart it, and we refresh. Now you can see that B will have the default value of 0. Again, it's really just a regular Java programming. Need to be concerned with null pointers and so on. So the getParameter method is probably the method that you are going to use the most often, but there are also a few other methods that deals with retrieving parameter names and values and so on. So there's this method called getParameterNames, and it will return all the parameters for this request. And this one may also be useful. So in HTTP, it's possible to have multiple parameters having the same name. Like we could have two parameters, both called A, and this is in fact allowed. And it's also a pretty common case when you have, for example, checkboxes in your web form, and all those checkboxes will have different values but the same parameter name. And we'll deal with those type of parameters. What you can do is you can specify the parameter name and call this method getParameterValues. And this will return all the values for that parameter as a string array. So if, for example, in this case, if we call getParameterValues A, we'll get a string array that has the string 10 and the string 20 in it. And that's quite useful when you have to deal with checkboxes. And then you can iterate through this array and then get those values one by one. And one more method is you can use getParameterMap, and this will return all the parameters and their values in a map, with the map key being the parameter name and the map value being the parameter values. So in this example, we're specifying the parameters as query strings in a URL, and but a more common way to do to supply parameters is to use web forms. So let's still use this example, but let's do it using a web form. So a web form can be pretty simple. We can simply create a HTML page to do that. So let's say we create a HTML page called add form. And as for the type of the HTML, let's use 4.01 transitional, and here we'll create a form to supply parameters to the add servlet. Now we know that to create a form, you need a form. You need a form tag, and the form tag should have at least 2 attributes, action and method, and then we can create a few form fields. In this case, we'll have a form field for A, and the input name is going to be A, and then type is going to be text. This will create a text field, and we'll do the same thing for B. And then we'll also need a submit button. Let's create a submit button. Name, we'll call it add, value is add. And the action is going to be add, and method, let's put get here. Let's run this code and make sure it works, and then we'll explain a few things related to this code. So now we have this add form, and to access that add form is simply add form.html. Notice that add form is directly under web content that corresponds to the root path of the application. So it's the application/add form.html, and it shows our form. So let's say we put 100 here, let's say we put 21 here, and we click add, and it shows the result. Works perfectly, right? Now let's explain a few things related to this form. Now, we know about the form tags, and if you forgot about your previous coursework on HTML and so on, please review some of your course materials. In particular, you'll want to review the tags related to forms, the form tag, and the input tag that can be used to create text fields, password fields, submit, reset button, checkboxes, radio buttons, and so on. All of those can be used, can be created using the input tag. And then the text area tag to create a input text area rather than just a single line of input field, and then the select and option tag that can be used to create lists and drop-down list and so on. So we are not going to discuss more about these tags per se in the class. You need to know how to use those form tags. What I do want to mention this couple of attributes in the form tag. The first one is the action attribute, and the action attribute needs a URL that corresponds to the server-side program that handles this submitted data. And in here we are specifying the URL to be add, and that looks simple, but when it comes to URL, it's kind of it's a bit complicated than what it looks. There are several types of URLs. There's the so-called absolute URL. Absolute URL is a full URL with HTTP and then the full hostname path and so on. So in our case, the full URL for add would be something like localhost 8080 and then CS320 add would be something like this. So you could put, for example, this here, and it would work perfectly fine. Now, the problem, however, with this absolute tag is that notice that the host name and the port number are hard-coded in your code. Now, the problem of doing that is when you finish develop your web application on your local host and will deploy your application on a different server. Now, this host name now is no longer valid. For example, if you put your code like this on CS3, it won't work because the host name now should be cs3.calstate.la.edu. It's no longer a localhost. So generally speaking, absolute URL is the most clear and the most explicit, but it could create problem when you need to deploy your application on a different server. So absolute URL is something that you should avoid when you specify the URL for the action in your form. So if we don't use absolute URL, we can use the so-called relative URL. Unfortunately, there are several different relative URLs, and that makes things quite a bit confusing. So there's a relative URL that's relative to the server root. So what does that mean? It means if we put, let's say, /add here. Now, this is a relative URL, and it has a leading slash. This indicates that this URL is relative to the root of the server. What does that mean? If, for example, we try this, and we say A is 100 and B is 200, and we click add. Now, we're not going to get anything here because notice the URL. So the request is now sent to add directly under this server. It's not the add that's under the server and under our application CS320. Right? So this is the relative URL that's relative to the server host, and this, as you can see, is probably something that you don't want to use. You might be thinking, okay, so instead of doing /add, maybe we can do /320/add. Now this is still relative to the server root, but now we have the application encoded in here, and this should work, right? And this indeed works. Now, the problem of doing this, however, is that once again, after you finish developing the application on your computer and deploy it on a different server, the application context for your application may be different. On your computer, your project may be called CS320. However, when you deploy the code on the server, CS320 may become something like CS320 STU31. Again, when you hard code your application name or your application context name in your form or in your code, then that could lead to problems when your application is deployed on a server that assigns a different application context to your application. So this, again, is not a good idea. So in Java Servlet, sometimes you can specify relative URLs that relative to the application root instead of the server root. A good example of that is the servlet URL mapping. Notice that this one again is starting with a slash and then add. However, this one does not correspond to the server root. It corresponds to the application root of your application. So the application server automatically append the context path of your application in front of it. And this is something that we want. And because it automatically adjusts the context path before the relative URL. And this, however, is not something that's natively provided by HTTP. So in Java Servlet, Web Servlet URL mapping uses the relative to application root URL, and later on we'll see a custom tag called redirect. Redirect also uses application root, and the response send redirect, if I'm not mistaken, also uses application root. So only when you use certain tags or methods provided by the Servlet library, it will allow you to create a relative URL relative to the application root. So although this is nice and this is what we want, but to use this is the usage of this is somewhat limited. Now the easiest thing to do is to create a URL that's relative to the current URL, and that's what we did before, which is just specifying add without any leading slash or anything. So what this one means is that this URL is interpreted as relative to the current URL, and the current URL, as you can see, is this one. So add is relative to the current one under the current paths. So it's equivalent to this one, which is relative to the parent path of the current URL. And this is a HTTP standard way of interpreting relative URLs, and it doesn't require you to use any specific method or tag to make it work. So whenever possible, you would want to use this URL, but be careful that it's relative to the current URL. In other words, it's relative to the parent path of the current URL. And sometimes you need to be careful when you do this. And but I guess more complex situations only arises when you have fairly complex URL schemes, and for most of the servlet code that we write, is probably won't get that complex. So bottom line is try to use this relative to current URL as much as possible. And this is a story about URL. Now there's the second method, a second attribute called method. And now that we know request method, we know that this basically defines what request the browser will use to send the parameters to the server. And right now we are using get, and if we go back to that page here, we specify the method to be get, and if we provide two parameters and then click add, notice that these are the three parameters. The A, the B, and the submit button also counts as its own parameter. And all three parameters are specified in the URL, and that's how the get method works. For a get request, the parameters are specified as part of the URL as the so-called query string. So what if we use post method instead? First of all, notice that when we change it to post, nothing here, right? And in fact, we are getting indeed nothing at all. The reason is actually pretty simple. Remember that when we create our servlet, we only put code in do get, and if the request is coming in as a post request, then there's no code that handles that, right? So that's why the response is empty. As we mentioned earlier, if you want to handle both get and post requests, and the way you handle them are the same, then simply call one method from the other method. So inside do post, we simply call do get and pass the request and response to do get. And that should do it. And let's wait until the server restarts. And let's go back to the form, refresh, and then again. So now it works fine. And it just takes one more line here. Now, the second thing I want to mention about this is notice that when the method of the form is post, the parameters are no longer in the URL. And where are the parameters? If you use TCP/IP monitor to monitor a post request, you'll see that those parameters are actually encoded inside the message body part of the request. So it's no longer in the URL. Generally speaking, for most of the form processing cases, you would want to use post as the form method. The reason being that there's a length limitation on the URL. For most browsers, I believe the length is I think 1K characters or something like that. So if you have a form that a user can type in lots of text, for example, in a web forum where a user can create a long post, then encoding all of the data in the URL may not be even possible. Not to mention it's undesirable. So in most cases, you'll probably want to use post as your form method. But of course, it's just a recommendation. If, for example, your form is very simple, it's only 2 very short input fields, then it doesn't matter that much whether you use get or post. Okay, so this is the story about web forms, the tags, the attributes, URL, method, and so on. Oh, there's one additional attribute for HTML forms called encoding type, and this attribute, usually you don't have to use it quite often. The only time that you have to use it is when you use a web form to upload a file to the server. And later on, we'll see an example. In a separate class, we'll see how to handle uploaded files and so on. But for a regular input, you don't have to specify the encoding type attribute. Okay. Now that we know how to process request parameters and use HTML forms, it's time to do a more complex example, the guestbook. Guestbook used to be pretty popular in the 90s. At that time, having a website is pretty rare, and people like to have a guestbook on their website so their visitors can leave them some messages. These days, instead of guestbook, people have Facebook. But the guestbook example remains my favorite example, as although it's very simple, it includes all the common operations in a typical web application, like add, edit, display, delete, session tracking, and so on. It's no exaggeration to say if you know how to program Guestbook, you know how to program most of the web applications out there. When we look at an application like a Guestbook, the first question, and also the most important question, is where do we start? Here is a big secret. The vast majority of web applications can be broken down into data and operations on the data. For example, for a guestbook, the data are these guestbook entries, which contains a name and a message, and the operations are displaying these entries, add a new entry, edit entry, delete entry, and so on. If you look at some other web applications, for example, an online store, then the data would be the products, the customers, and the orders, and the operations would be displaying the products, register a customer, place an order, and so on. So when it comes to web application development, the first thing you want to do is to identify the data, create some data structures to hold the data, and then you implement those operations one at a time. For our guestbook example, the data are the guestbook entries. Each entry has a name and a message, and we know we can create a class for that. We'll also need to manage a number of these entries, so we'll use a Java list to hold those entries. There are 4 operations: display, add, edit, and delete, and we'll create a servlet for each operation. Let's start with the simplest operation, which is typically the display. Before we do that, we'll create a class that holds our data, and we'll call that class guestbook entry. You can put this class in any package. I'm going to put it under a package called CS320 model. The reason it's called model is this type of classes are often called data models or data model classes because they are the classes that are used to model the data we try to manage. And just like any regular Java class, we create a couple of fields. We'll say private, and we'll have a name, and we'll also have a message. Let's create a couple of constructors. I usually like to have a default constructor, and in this case, we also probably want a constructor that takes a name and a message to initialize the 2 fields. So this will be this dot name is name, and this dot name is this dot message is message. Notice that both the parameter and the field have the same name. So this dot name refers to the field, and then name itself would refer to the parameter here. And because those 2 fields are private, let's also create a couple of getters and setters. The easiest way to create getters and setters is to let Eclipse to generate those getters and setters for you. So right-click here, select source, and then select generate getters and setters. We want getters and setters of both, so select all, and that's that. Right? Not only it's easy to generate getters and setters this way, it's less error prone. If you typing everything, it's very easy to make a typo. So this would be our data model class, and as you can see, it's very simple, and it's just a regular Java class, has nothing to do with web applications and everything. And that's a good thing, because if, for example, you don't like web applications and you want to write a desktop application for this, then this data model classes can be reused for desktop applications as well. They are independent of the user interface. Now with that, let's create the display operation, and we'll call it display guestbook, and that will need to be a servlet. Let's just call it guestbook. So in this servlet, it needs to initialize the data storage for the guestbook entries. So we'll need the init method. For the init method, remember to call the super class init method first, and then we'll create a list of guestbook entries. So we'll say guestbook entries, and we'll use an array for that. Now, right now, this list is empty, and theoretically, you need to create the add operation before you can display anything. But add operation is often more involved than display operations. So a simple trick is to pre-create some data so that you can implement the display operation independent of the add operation. And so let's pre-create some data. We'll say entries, add a new entry, and let's say John says hello, and let's say Joe said nice site. Now we have two entries, and then let's save the list in the application context, just like we did before, so that this data can be shared among multiple servlets, each servlet implementing one operation. So we'll have get servlet context, and then add attribute. Is it add or set? Set attribute. Set attribute. Let's call it entries and entries. Okay, so now we have initialized our data. We store the data in the application scope, and since we're doing that, might as well put the load on startup here. Load on startup, so that the data is always initialized before any other servlets are accessed. For do get and do post, the display guestbook will always be accessed using by GET request, so we don't really have to have this. But just in case, let's leave do post here. This pass. Now the display part can be done fairly easily. It's really just using a bunch of print statements to generate a page that contains presumably a list like this. So yeah, so let's do that again. Let's copy over the display code, and this one is the Guestbook, and we're going to use a table to show the Guestbook entries. So that means we'll have Guestbook here, and then we'll have a table. Let's put a border in there so we can see the table, and then let's close the table. And then we have to display the entries. Now there are two things here. First, we have to retrieve those entries from the application scope, and then we have to iterate through those entries, and for each entry produce one table row. So let's retrieve the entries here. So the entries will be entries, and then we'll do get servlet context and get attribute. And since attributes are objects, again we'll have to do a cast. Let's cast this to entries. Okay, and if you don't like the warning, we can add a suppress warning here. Now we have the entries, and then we can do here for each entry. We'll produce one row, and that one row is tr, then td, and then let's say entry get name says and entry dot get message tr. Okay, so that should do it. Why there's an error here? Okay. Now let's run this and see if it works. Right. Okay, we need a space in there, but that's more or less it. Oh, and maybe just to make it look nicer, let's create a tr name. Let's create a header row message. Okay, and that more or less is the display part, and yes, there's not too much here. Most of the code here we can see are something we already know from previous lessons, accessing application scope and then generate some display. And generating a table is no different than generating other HTML content. Now the main thing about this display operation is that you want to pre-create some data to make sure that your display works even before you implement the add operation. It's important, although this is a simple example, it's important to understand that the importance of implementing one operation at a time. If you try to do too much at the same time, debugging becomes a lot more difficult. So implement the simplest operation, which typically is the display operation, and then use some pre-created data to test it before we move on to the next operation. Now the display is working. We can do the next operation, and that will be add. And for add, we'll create a link on the page so that the user can click on that to leave some comment. Let me stop the server here, and let me add an additional line here that says leave a comment, and this one will have the link add comment. Yes. Okay. So the add comment page will look like this. It will have an input field where people can leave their name, and then they can leave some nice message here in a text area. So for the add operation, it's a very typical form processing operation where you display a form and then you process the data submitted from that form. And that typically involves two operations: form display and form processing. Convention for Java Servlet is that you can use one servlet to implement both the display and the processing part. And we can put display part in doGet, and we can put the submission part in doPost. So let's create that. And we are going to call it add comment. We'll have both doGet and doPost. In doGet, we simply display the form, and that's pretty simple to do. Let's grab the code for display. And this one will be add comment. And the form will be form action is something, method is something, form. So remember, action is the URL for the servlet that's going to process the form submission, and since we plan to use the same servlet to process the form, that action will be add comment. Notice that this is a relative URL, and the post method determines the method of the request for the form submission. And since we are going to use the doPost method to process the form, the method here, of course, needs to be post. And let's close the form, and in between, let's print out the fields. So the name field will be an input, type is text, name is name, and the message is going to be a text area, and this one will be the message attribute. And let's say we have 5 rows and 60 columns. Let's see how it looks like. Okay, something like this. So nothing too special here, it's just displaying the form, and then we need to process the submission. So to process the submission, just like before, we'll do request get parameter name, and then request get parameter message. And we need to retrieve the entries from the application scope and then create a new entry and add to it. So retrieve the entries from the application scope. Again, suppress warning. Actually, let's suppress warning as a method level. And entries. Add new guestbook entry and the name and message. Okay, so this should add the new guestbook entry to the list of entries we already have, and then we want to send the user back to Guestbook display, and that we can use a method called send redirect response send redirect, and we'll redirect the user back to Guestbook. Okay, so let's see if this thing works. The server, let's add another one here, Guestbook. Okay, click Guestbook. We have two entries here. Leave a comment. So this is the do get part of add comment, displaying two fields. I guess I forgot a submit button. So let's go back and add a submit button. Submit, name is that, value is that. Okay. Restart. Okay. Refresh. What's happening here? Input type. Oh, missed a code there. Okay, so now we have our button here. So let's say Tom says hello and add, and now we have Tom says hello here. Right? And in this example, there are a couple of things. The first thing is form processing, which involves two operations, form display and processing the submission. And typically in Servlet, we split them into the do get and do post of one servlet. Another thing in this example is the send redirect method in response, and we can use that to redirect the user to a different URL, and that's typically something we should do after adding a new item to the application. Okay, so now we have add and display. Let's implement edit, and edit would let's add an additional link to each entry, so we can edit an entry. Let me again stop here and then go back to here. So add another column, operations, and for each entry we'll say we'll add a link here, add a link that says edit. Something like this. Okay, let's run this first and see if we can see the link first. Okay, we can see the link here, and supposedly if I click on edit, it will take us to a page where we can edit the first entry, John and hello. Okay. Now, obviously, we haven't implemented the servlet yet, so there's nothing here. But more importantly, notice the URL. It says edit entry, but it doesn't say which entry to edit, and that's a problem. Remember, the input for a web application is the HTTP request, so the request has to contain everything we need in order to perform that operation. And this request obviously is missing something important, and that's which entry we need to edit. Now, a simple way to rectify that is to add, for example, the index of this entry within the array, and that should tell us which entry to edit. And so let's change that. And here, for this link, we have to include some identifier for the entry to be edited. And let's use the array index for now. So what we do is, instead of doing this one, we'll do int I is 0, I is less than entries.length size plus I. So we have the name, we have the message, and then here inside the link we'll need to put an index, and that index will be I, and let's add this. Okay, so save, run, edit. Now we see that now we have a request parameter called index, and for the first one is 0, for the second one is 1, and now we have enough to work with. Okay. So then let's create the edit comment part, edit entry part. Now edit is in fact quite similar to add. Now for a add operation, you display a form, and the form is typically empty. And for edit, you display a form, and the form should be pre-filled with whatever current data is. But if you look at these two operations, they look quite similar. So because of that, we can simply make a copy of add comment, and we'll call it edit entry. And remember to change the URL mapping, and here it will be called edit entry. And similarly, the action will go back to edit entry. Now, here we used to have an empty form, and now we need to pre-fill the form with the current data, and that of course requires us to get the entries from the application context, and then we want to get the index from the request parameter. So the index will be integer.parseInt request get parameter index. And once we have the index, we have the entry, and that entry will be entries get index. And once we have the entry, we can pre-fill the form. So here input is type and name, and it will have a value, and the value will be entry.getName. And similarly, the text area will have the value, and the value will be entry.getMessage. Yes. Okay. Now let's modify the do post part. We get the name, which is provided by the input tag. We get the message, which is provided by the text area, and we retrieve the entries, and then instead of adding a new guestbook entry, we have to retrieve the entry to be edited and change the name and message. However, notice that here, just like in doGet, we need an index in order to find which entry to edit. However, if you look at the form has a name field, it has a message field, but it doesn't have any other parameter that tells us what's the index for that entry. Again, remember the request is the only input your web application has, and the request need to provide all the information for your web application. If the request doesn't have it, you have to somehow put the information in there. Now, in this example, in the display example, notice that in order to provide the information, we embed the array index in our URL. And here it's no longer a URL. We have to embed the array index somewhere inside this form. And if you are familiar with your form tags, you'll remember that there's a so-called hidden form field that you can use. And the hidden form field is a field that's not displayed to the user, but you can use that to embed some information in the form, so that when the form is submitted, you have that additional parameter to utilize. And so here, instead of just the two fields, we'll have an additional field. and that additional field is going to have the type hidden, and the name is going to be index, and the value of that field is going to be the index. Okay, so with this hidden form field, now we will have an additional parameter here, and that parameter is going to be index. Okay. And with that, we can do entries, get index, and then we set the name to be the new name, and we set the message to be the new message. And then we send the user back to the display. So let's see if this works. So Guestbook, edit. Notice that it prefills the form with John and hello. If we click edit this one, it's Joe and nice site. Okay. And then let's change the name to Jane, and let's change the message, say, I really like your site. And then we click save. It changes to Jane says, I really like your site. So this example for the edit operation, the main thing here is we need to embed an identifier of some sort in either the generated hyperlink or a form, so that on the server side we know which entry to edit. And so we have changed the guestbook display part, which include index, and we also changed the form display part, which has a hidden form field. So this is the important thing, and it's also a pretty common trick used by web applications to embed information for the other operations that's going to use. Another thing we can learn from this example is that editing is really not that different from adding. So we'll create an edit operation, simply reuse the code from the add operation, and then add a few additional things like the identifiers or the prefill the form and so on. But lots of code that in there that you can reuse. Now let's implement the last operation, which is delete, and we'll add a delete link here, and similarly it should tell us which entry to delete. So let's add a delete link. So here it will say delete entry index is so this should close the in tag, something like this. Let's run this. Okay, delete is not shown correctly. Edit. Oh, close the cell too early. Okay. This one should be here. Okay, so now we have the delete. If I click here, it shows delete index 0. It do here, delete index 1. So that should work. And then let's implement the delete. Delete entry. Let's ignore the post part. Okay, so delete conceptually is pretty easy to implement. All we need to do is get the entries and get the parameter index, and then delete that entry from the entries. So we get the entries from the application scope, and we get the index from the parameter, and then we do entries remove index, and then we do a redirect. And this should be it. Let's see if it works. Guestbook, let's add a comment. CY_Sound says hi. And let's delete Joe. Joe is deleted. Delete John. John is deleted. Right. So as you can see, delete by and large is pretty easy to implement. Now there is, however, a problem. So let's say, for example, let's go back to this, add another one. Let's say Joe, and Joe says hello, and then let's say Jen, and Jen says nice site. Okay, so now we have 3 entries, and the thing with web applications is that you could have multiple users accessing your web application at the same time. So let's use a different browser to simulate another user. So now I have 2 users, and both of them are looking at this guestbook, and here. Now let's say this user wants to delete the first entry, CY_Sound. So this user click delete, and CY_Sound is gone. Notice, however, that the other user is still seeing these 3 entries, and that could cause a problem. For example, if this user also tries to delete CY_Sound, and the user will click this link to delete. However, notice that this link delete not CY_Sound, it delete whatever the first entry in the entry list. However, because the other user already deleted CY_Sum, now the first entry in the list is now Joe's entry. So if this user click delete, instead of deleting something that's already deleted, it will actually delete the second entry, Joe's entry, and obviously that's not something we want to happen. Another possible bad thing that could happen is that, let's say this user wants to delete Jane's entry by clicking this link. However, because another user already deleted one entry, clicking this link will delete an entry that no longer exists, because now Jane's entry becomes the second entry instead of the third entry. So for example, if we click here, we're going to have an error, and that error says index out of bound because index number 2 no longer exists. This problem arises because we're using array index as the identifier for an entry, and that's a poor choice for an identifier. Ideally, when we want to use an identifier to identify an entry, it should be something that is unique but also immutable, meaning that operations changing the data should not change the identifier. And this is particularly important for web applications that allows multiple users accessing the same data at the same time. So a simple way to create a immutable identifier is to assign an ID to each entry, and that ID will be unique and it will never change. So one possible solution for that problem is to create an ID field, and so let's say we'll use an ID field. And so let's add that ID field. Okay, and then when a new entry is created, we have to assign an ID field to that entry, and since that happens inside add comment, what we can do is we can use a ID seed field in the ID comment, and each time a new entry is created, we give it the current value of ID seed, and then after that we increment ID seed. So this will give each new entry a unique ID value. And then let's say if we, so here when we display the links for the edit, here when we display the links for the edit and delete operations, we'll change the parameter of the link. Instead of using index, we'll say let's use ID, and the ID will be the entry's ID. And similarly, this one will do ID and then entry dot get ID. And okay, so let's say this one will have ID 1 and this one will have ID 2. And then inside delete, instead of getting the index will get the ID, and then we need to locate the entries that have the ID. So we'll say for int I is 0, I is less than entries dot size. We'll say if entries get I get ID equals to the ID, we'll do a entry remove I, and we break out of the loop. Something like this. Okay, so obviously you also need to change the edit entry code to also use ID instead of index, but I'll leave that to you. Let's run this code and see if we have fixed the problem of the delete. So we have the guestbook here. Let's add one more comment. Let's say Jen says hello. Again, now we have 3 entries here, and let's go to this browser. We see 3 entries here. Now, if you look at the URL of the delete link, now it should show ID instead of index, and it's showing ID 1, and we need to change that to add an equal sign, and ID equals yes. So this should do it. Close others. Let's add one more. Says hi. Okay, so if we look at the ID link to the delete, it said delete entry ID is 1, and if we look at another one, delete entry ID is 100, something like this. So again, let's use a different browser, same entry here. Now let's say that this user will delete John's entry. Click delete, John's entry is gone. And now on this side, it should still showing John's entry, and that's fine because this data is cached by the browser. It doesn't automatically change when the data on the server changed. Now the good thing is that now if we click on delete, and it should delete Jen's entry instead of giving us an error, because now it deletes based on ID instead of basing on index. So see, both John's entry and Jen's entry are now deleted, and then there's only one entry left, which is Joe's entry. So the lesson for the delete operation is that first of all, it's a relatively simple operation to implement. You get the ID of whatever you want to delete, delete it, and then redirect to display. More important thing that we learned here is that when you want to have an identifier to identify certain data item that you manage, and that identifier needs to be unique and immutable, and otherwise it may create problems when multiple users have concurrent access to your web application. Okay, so this is the end of this lesson, and here's a quick summary. The most important thing in this lesson is to understand that web applications really are just data plus operations on the data, and once you identify your data, you can implement those operations one by one, and it's not very hard to do. Okay, so that's it for this lesson. See you next time.